Trig equations with an angle multiplied by a constant. All right, these last two topics are a little bit more tricky than the previous problem ones we've had, where it all broke down into a fairly simple question of find the x value or find the y value, and then tell me which angle. Um, these ones are a little bit more tricky, and this one and both the next video. And if your worksheet looks slightly different than this, please go to Canvas and download the updated worksheet because there was a math error on the original one. All right. So these problems, we're back to finding answers that are within an interval from 0 to 2 pi. The difference is instead of it just being a theta or an x in here, it's something like 3x, 2x, 4x, x over 2, 3 halves x, something that's not just an x. And if we had the correct formula, if this were a 2, we could use a double angle formula. If we had that ability, we would do that. But what if you're in a situation here where there's no double angle formula for this? And I need to find the solution. What x values do I need to plug in there in order to make the statement true? Now, with a problem like this, you start the problem off very similarly to the way you would start it as if it were asking for all solutions, not just the 0 to 2 pi solution. So that part where you add the 2 pi k on. And I'll tell you why in just a moment. So first, start to solve this just like normal, right? Add the or subtract the negative root square root, subtract the square root 3, divide by 2. You end up with sine of 3x is equal to negative square root 3 over 2. Now, I want to just stop right here, right at this moment. Sine of 3x is equal to negative square root 3 over 2. I am going to come over to this unit circle, right? And just like, we always have, we're looking for the y value to be negative. So bottom half of the circle. Negative square root 3 over 2. That happens at 4 pi over 3. Made the circle pretty small. And at 5 pi over 3. And you'll see that, again, I have these answers up here as the original part and the plus 2 pi k for the coterminal. But before we do anything else, and you can see there's more to do here, why? Why am I setting it up like this? Well, when it was just the angle, right, we would be done. These would be our answers, 4 pi over 3, 5 pi over 3. That'd be fine. Now, let me share my screen. Okay. This right here is the graph of just regular sine of x from 0 to 2 pi. So it starts here at 0, goes to 2 pi. There it is. And if we were looking at it being equal to negative square root 3 over 2, you can see there are 2 times where that happens here at 4 pi over 3 and then at 5 pi over 3. Those are the 2 answers we found, right? If this is just regular sine of x. However, if instead it's sine of 3x, that oscillates. So it goes up and down. It oscillates faster than sine of x. And look, there's not just 2 places where these things intersect, where this function sine of 3x is equal to negative square root 3 over 2. There are 1, 2, 3, 4, 5, 6 locations where that's true. So we have to figure out how to find these missing points here. So you set it up as if this were anything, right? As if this were a, theta. If this were a theta, you would say theta equals, or theta, theta equals 4 pi over 3, theta equals 5 pi over 3. You just put whatever's in there here. So 3x is 3x, 3x. This is really important. We're going to take each of these equations and we're going to solve for x, and then we're going to plug in values for k. We said k was any coterminal angle, right? So we're saying when you multiply x by 3, whatever angle we find by 3, then the answers will all be of the form 4 pi over 3 and any coterminal angle, 5 pi over 3, any coterminal angle. But this is once you've multiplied the angle by 3. So we solve for x here. To get rid of the 3, we are dividing everything by 3. So that's what happens from this step to this step here. And let me do this. Okay. So from this step here to this step here, everything is divided by 3. When you divide 4 pi over 3 by 3, this becomes not 4 pi over 9. And when you divide the 2 pi k by 3, it just becomes 2 pi k over 3. Now, we are going to be plugging in values for k, which means we want to be able to add these fractions together nicely and easily. So what I did is I said, hey, I would like to make a common denominator between these two fractions. And that would be easy if I made this guy into a 9. So if I multiply the numerator and denominator by 3, 2 times 3, that's where I get that 6. And then 3 times 3 is 9. Now these have the same denominator. It just makes it a little easier to work with. I did the same thing over here. Divide both sides by 3, 5 pi over 9 plus 2 pi k over 3, and then made a common denominator. The steps are now plug in values of k and make sure they're within the interval 0 to 2 pi. Now, all of our answers are going to end up with denominators of 9 because that's how we've set it up. And we've talked about this mental math before. We're looking at anything between 0 pi over 9, and then 2 pi is the same thing as 18 pi over 9, twice that denominator. So our answers need to be between 0 and 18 pi over 9. We want that numerator between 0 and 18. Has to be less than 18, can't be equal to 18. All right. So we start by plugging in 0. We plug in 0 for k. K is now 0. This whole thing becomes 0. 4 pi over 9 as the answer. Plugging in 1. So, and 4 pi over 9, that is definitely in the interval, right? So we're good. I'm going to circle you, I'm going to highlight you. You are an answer. And then the next one, I plug in a 1 for k. Once I plug in a 1 for k, this is going to be 1 times 6 is 6. So you have 4 pi plus 6 pi, 4 pi over 9 plus 6 pi over 9. That is 10 pi over 9. That fits within the interval we're looking for. So that's an answer. And then I plug 2 in. 6 times 2 is 12. So 4 pi plus 12 pi is 16 pi over 9. That also fits within the interval. So that's an answer. Then I plug in 3. So I keep going until I exceed the interval. I plug in 3. 3 times 6 is 18. So I have 4 pi plus 18 pi is 22 pi over 9. 22 pi over 9, that does not fit in the interval 0. That is greater than 18 pi over 9. So it's not within our 0 to 2 pi interval. So that guy is a no. And we stop. So we have 3 answers so far from that first equation that worked. And then we do the same thing over here. Plug in 0, you get the answer 5 pi over 9, that works. You plug in 1, you're going to get 11 pi over 9, that works. If you plug in 2, you get 17 pi over 9, that works. And then when you plug in 3, you get 23 pi over 9, which will not work. So there is a total of 6 answers for this problem, and I should have left space to put what the answers are, but our final answer, oops, see here, is x equals, we have 4 pi over 9, 5 pi over 9. I'm just kind of reading them in order. 4, 5, 10, 11, 16, 17. See, 5 pi over 9, 10 pi over 9, 11 pi over 9, 16 pi over 9, and 17 pi over 9 are all of the answers to this one. All right, so this is the process. And let me show you, I'll share Desmos. Let me share with you that indeed 4 pi over 9, 5 pi over 9, 10 pi over 9, 11 pi over 9, 16 pi over 9, and 17 pi over 9 are the solutions to this. Those are the times where sine of 3x is equal to negative square root 3 over 2. Okay, so let's do this process from scratch on our own without having it typed out in front of us. What does this look like when we're actually doing it? So we see with this, we're solving a problem from 0 to 2 pi, and we have not just a regular angle in there, it's 2/3 the angle. We solve it like it was an all solution problem. I am going to add the 2, the square root 2 over. I'm going to divide both sides by 2. You end up with cosine of, let's just make sure I leave room. Cosine of, I'm going to write this as 2/3 x. Not that it matters, you can write it however you want. 2/3 x is equal to square root 2 over 2. This is referring to an x value. Cosine refers to x values. So I come over to the unit circle. I say, where are the x values? Square root 2 over 2. X values are positive on the right half of the circle. So that's going to be at pi over 4 and at 7 pi over 4. So those are the times originally. Right? This happens at pi over 4 and 7 pi over 4. So we're going to split this into two equations. We're taking this entire angle in here, 2/3 x is equal to pi over 4 plus 2 pi k. And maybe actually I'll make this whole thing. I'll make this whole thing blue. Okay. And our other equation will be room, hopefully, 2/3 x equals 7 pi over 4 plus 2 pi k. All right, to simplify this, to solve for x, I'm multiplying both sides by the reciprocal of that fraction in front of x. So I'm going to be multiplying this guy by 3/2, and I'm going to be multiplying this guy by 3/2. Everything multiplied by 3/2. The 2 will cancel, the 3 will cancel. You are just left with x. Then we have, this will become 3 pi over 8. On the other side, these 2's will cancel, and that becomes 3 pi k as our equation. And now we are going to plug in values of k for it. So we're going to, let's see, start with k equals 0, always. Start with k equals 0. You would get x equal to, and then this whole thing will just turn into 0, right? 3 pi times 0 is 0. So you'll just get 3 pi over 8 as a solution. And that one works. 3 pi over 8. We want this, we want these to be in the interval 0 to 2 pi. And that interval is going to be 0 pi, if we're doing denominators of 8, 0 pi over 8 to 16 pi over 8. So we need our numerators to be less than 16. When I go to do k equals 1, it would help if my denominator on this guy here were an 8, and I forgot to do that initially. So let's go and do that. To make the denominator into an 8, I'm going to need to multiply by 8 on top and bottom. I get x is equal to 3 pi over 8 plus, this will be 24 pi k divided by 8. This is just helpful here because if I have to add these fractions together, I could use a calculator. You're always welcome to use a calculator. But if I have to add them together, it's useful for them to have the same denominator because the math is a lot faster that way. All right. So plugging in 1, we have 3 pi over 8 plus 24 pi times 1 over 8. Let's see, and this was an answer originally. We get 3 plus 24 is 27 pi over 8. 27 pi over 8 is far outside of our acceptable range of 0 pi over 8 to 16 pi over 8. So that guy is a no when we stop because we've exceeded. He's not in 0 to 2 pi. In 0 to 2 pi. And then we come over to our other equation. We are going to similarly multiply by 3 halves on everything. So I'm back here. Times 3 halves times 3 halves. These two cancel, those threes cancel. Over on the other side, we have x is equal to 21 pi over 8. I'm just multiplying the numerators and then multiplying the denominators. Plus, these twos cancel, and you end up with 3 pi k, just like the other side. And I'm also going to make it have a common denominator, just like I did on the other side. So I want the denominator to be 8, for both of these terms, multiplying by 8 on top and bottom. I get x equal to 21 pi over 8 plus 24 pi k over 8. So immediately I'm starting to feel like, oh, something doesn't feel right. And the something that doesn't feel right is, hey, when I plug in 0, like this thing doesn't even exist in the 16 pi over 8. So we might only have one answer. And let's look further into that. So I'm going to plug in k equals 0. That's where you always start. And you would have x equals 21 pi over 8 plus 0. And this guy immediately is not in 0 to 2 pi. I had actually done this problem wrong on my notes. I had done a tiny bit of algebra mistake on my notes. And I had paused there and was like, oh, what mistake did I make? And I had just a silly fraction thing. There is only one answer, and that was a little shocking to me. And I think that it's worth looking at a little deeper. So the only answer to this one is 3 pi over 8. Boom, wham, bam, thank you, ma'am. And I'm going to share my screen. I'm going to look at the graph of this. So here's the graph of just regular cosine x. If you'll remember, what we had was cosine of 2/3 x is equal to square root 2 over 2. So this is regular cosine x, and this is square root 2 over 2. So you can see there are 2 times regular cosine is equal to square root 2 over 2. However, turn off cosine. If I do cosine of 2/3 x, look at this graph. Because it oscillates slower, this number is less than 1, it oscillates slower than a regular cosine. The only time it intersects is here at 3 pi over 8. It doesn't intersect it again. So that's fun. All right. One last problem. And then this problem is a doozy. Just going to go ahead and warn you, this problem has a heck of a lot of answers, but we're gonna do it. We're gonna use a calculator to do a lot of the math here. Just warning you. I would like to also point out, do notice here, when we were doing this original problem, that these denominators went up by 6 each time. Went 4 pi, 4 plus 6 is 10, 10 plus 6 is 16, 16 plus 6 is 22. Over here, 5 plus 6 is 11, 11 plus 6 is 17, 17 plus 6 is 23. And it is no coincidence that the number over here was 6 pi over 9. You're just adding an additional 6 pi over 9 each time. So that's how those numbers were jumping. So if I had recognized that pattern, as long as you have a starting place and you have a common denominator here, you can just keep on adding that number over and over again. You'll see that same thing here. So it would have jumped by 24 pi's each time. The bigger the number in the inside here, the faster it oscillates, the more answers you'll have. So if this number on the inside is less than 1, you'll end up with less answers. If it's greater than 1, you'll end up with more answers. Going to solve this, we have cosecant of 5x is equal to, subtract 4 on both sides, 1. We look at the soulmate. You are obligated to put a heart. The soulmate of cosecant, which is sine. So sine of 5x is equal to the reciprocal of 1, which is just 1. We say, hey, I made an error on my, hold on, I made an error on my notes again on this problem. All right, I went off on a complete wrong tangent in my own note. Anyway, let's go. Sine of 5x is equal to 1. We're going to ask ourselves, I don't know how many answers this one's going to have. The math I did originally, I'm seeing an error in it. I had 8 answers originally. Let's find out. Where is this will be y value. Where is the y value 1 on the unit circle? Well, it only happens at one place, right up here at pi over 2. So we start this out by saying 5x, that angle, is equal to pi over 2 plus 2 pi k. And to get x by itself, I am dividing, not by x, by 5, dividing everything by 5. You get x is equal to pi over 2 divided by 5 is pi over 10, plus 2 pi k over 5. I want these to have the same denominator, so I'm going to make both denominators 10, multiply by 2 on the bottom, multiply by 2 on the top. You end up with x equal to pi over 10 plus 4 pi k over 10, which means it's going to go up by 4 pi each time. Scoot these up a little bit, make myself some room. Actually, maybe I'll make my room over here. Maybe I'll make it over here. We'll start with k equals 0. When k is equal to 0, it is just this original answer here. So it is just x equals pi over 10. We are on the interval 0 to 2 pi, right? And as that relates to denominators of 10, we're looking at anything between 0 pi over 10 and 20 pi over 10, but it needs to be less than 20 pi. So pi over 10 works. That's one of our solutions. Plug in k equals 1. When you plug in k equals 1, you have pi over x equals pi over 10 plus 4 pi times 1 over 10, using, again, this formula right down here. Make a little note. Came up here. You get pi plus 4 pi is 5 pi. X is equal to 5 pi over 10, which is pi over 2. So pi over 2 is an answer. Pi over 10 is an answer. Pi over 2 is an answer. Plug in k equals 2. X is equal to pi over 10 plus 4 pi times 2 over 10. That's adding 8. 8 pi plus pi is 9 pi. So we have x is equal to 9 pi over 10. And that fits within there. It fits within our interval. They're just going to keep going up. You can see it already happened here, right? So it went from pi over 10 to 5 pi over 10. It went up by 4, went up by 4 again. It's just going to keep doing that. We can keep on writing it this way, and you can check the math out yourself. But the next one, 9 plus 4, is going to be 13 pi over 10, and that works in that interval. If you plug in k equals 4, boop, boop, you'll get x equal to add another 4 pi. So let's see, we went from 9 pi, added 4, we have 13 pi, add 4, we have 17 pi over 10. That fits in the interval. When you go to do, let's see, I guess I'm just going to move this whole thing. Boop, 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 boop. Everybody moves up. When you go to do k equals 5, you have x equals 17 plus 4 is 21 pi over 10, and that is not in 0 to 2 pi, which we again said was 0 pi over 10 to 20 pi over 10. So that number is too big. So the answers we have, x is equal to pi over 10, pi over 2, or you could say 5 pi over 10. It doesn't matter how you write it. You can write it pi over 10. You can write it pi over 2. These are the same answer. 9 pi over 10, 13 pi over 10, and 17 pi over 10. Still a lot of answers for this one. Oof. And that's that. Let me set up the graph real quick so I can show you because I think it's interesting. All right, so if you remember the original, when we settled the original equation, it was sine of 5x equals 1. So here is the graph of just regular sine x. Here is the line y equals 1. You can see there's one place where it hits. It's at pi over 2. That was the answer we found. But if you look at sine of 5x, this thing oscillates way faster. So it's pi over 10. Here's our pi over 2, 9 pi over 10. 13 pi over 10, and 17 pi over 10. So you can see each of those places where it's intersecting that line. So these ones, they're a little tricky. They're not bad once you get it down though. Just repeat, practice, 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 practice is perfect. And I will see you in the next video for the last video in this section. All right, bye.